AI agent. Does anyone have any idea why do we need this? You can unmute yourself or
you can tell us about it, because I'm sure that we have heard a lot about AI agents, but that would be great if you could give us or share with us your experience on the way you are using it as a DevOps person, because AI agent, to be honest, you can use it in every field. But yeah, how do you use it on a daily basis? And maybe what are the challenges that you found when you want to use it in the DevOps space?
in the DevOps space, what I have come is the biggest issue I can see is the logs. You see, when something goes wrong in the production, it can produce 1,000 logs at a time. It can be 100 logs at 10 minutes, 5 minutes, and this is really, I think, headache. And I have seen teams work with just a wall of Prometheus alerts, and everyone's basically trained themselves to ignore AI agents. They think that maybe we are not ready for this transition, but you see, this is actually happening right now. People are integrating AI agents into their pipeline. What my agenda is that if we build AI agents for log, it can solve a massive problem in DevOps Engineer. And we cannot train human on everything, but AI can adopt on everything. You see, when a new log can happen, AI can adopt immediately. But for the humans, it can be maybe they can take a day to understand that, and this is exactly what AI agent is solving. A point I can point out is that I have written here is that repetitive runbooks. This one gets me every time, and there are studies that says 80% of incident follows known pattern, but we still have engineers executing the same runbook steps manually every time. That's when a load happen, cognitive log, and you see that's burnout. And third point it's solving is MTTR at scale. When you have a complex distribution system, you see, diagnosing an incident requires someone who understands Kubernetes and the application log and the database and the CDN monitoring system. So the person can be rare, and AI agent can hold all of that context at once. The fourth point is the scale mismatch. So microservices can be great, but until we have 100 plus, 200 plus of them, human cognitive bandwidth is bottleneck. And I think integrating AI agents is really, really efficient nowadays. So let's talk about the stack that I have worked with, and I would suggest that you see the stack and the 5 layers that I have built on this for today's session is at the top of the layer we have the UI and API. It can be any framework, but specifically I have used Next.js, and I'm working with Next.js. It's that I have comfortable in that you can use any other framework. So we can build a dashboard from Next.js where our teams can see what the AI agents are doing. We can approve actions from that, and we can monitor incidents in real life. And underneath it's Fast API. I have used Fast API and it can handle the backend API very efficiently. The second layer we have is orchestrator layer. This is where our SDK is happening, OpenAI Agent SDK. And OpenAI Agent SDK, I think it manages everything. You can use another framework as well, but for the agentic logic, the instruction, the SDK is really Python first. If you know Python, you can actually build anything on Python, Agentic AI, OpenAI SDK. The third layer I have is MCP and Datadog. This is where our tech stack is, the DevOps tech stack is. You see, we have GitHub MCP, the Datadog MCP, Kubernetes, Slack, and DB. This is very important because MCP can give our AI agents a set of tools. It can perform actions to our GitHub, it can perform actions to our Datadog, our Kubernetes, it can send Slack notification, and it can also go through our database. The fourth infrastructure layer is Kubernetes Argo CD, and I have used Helm. So Kubernetes is where it runs everything, and Argo CD handles the GitHub deployments. The Helm manages the manifest. The fifth layer is at the bottom is observability, Prometheus, Grafana, and Opportunity. Because you know we can trust a system, we have AI, but we need something Kubernetes or any other tools that we need. Each of these layers is a full topic on its own. So let's go through one by one. Now let's talk about what exactly this OpenAI Agent SDK is doing behind our logic. You see, it is our backbone of agentic logic. Let me walk you through the four tools and optionally a handoff list. A handoff list is basically we will talk about handoff later. Let's first talk about the instructions. Instructions are our system's prompt. If you have knowledge about any LLM or any AI agents, we need to give them a system. And this is very important because system prompts can only be fitted once because our AI agents cannot do everything. If we want something for Kubernetes, we only need Kubernetes specialist. If we need GitOps deployment, we will only instruct them to do GitOps AI agents. And this is the same pattern we see in humans as well. You see, when we try to do everything, we fail eventually. So we have to master one thing and then we will apply to our jobs or anything that we are interested to work with. The second is here we can see is a runner. This is very special thing about OpenAI Agents SDK that it can execute the agent loop from its own. We only need to call that this runner dot run, and we have everything inside that. We will only call the runner dot run, and it will do the agent loop that we previously talked about. And third is tools. A tool is literally just type function in this SDK. You can decorate with, you see here I have this dot at the rate agent dot tool. It is very special that you can just put a decorator on any kind of function and we will get that tool, and we can actually give to that to our agents. You see, we only have 5 lines of code beside this, and this is it. Our agent is not production ready, but we can execute this agent in any kind of application, or we can say for testing. By looking at this code, this is all you need to define a DevOps agent. You give it a name, some instructions, and we just say fix the alert. And we will give them tools which we will be building from this decorator. And this is it. The LLM will figure out which tools to call and in what order. The fourth and main point I wanted to mention that guardrails. This is very important. So these are input and output validation hooks. Let's take an example. I have given my AI agent that restart this board. But before restarting, it need to check. We need to check that where it's going. We need to check that it don't hallucinate. It can do action on its own, but we need to make a wall before it get input or before it gets us the output. So this is a diagram that actually shows how guardrails will do in our agentic AI system. In this architecture, you see we have a triage agent at the left, and this is the orchestrator. You see, when our alert comes, the triage agent reads it and it will decide, is this a Kubernetes issue? Maybe I need to route it to the KATS agent. Or maybe it is a deployment failure. So it will route to the CI/CD agent. Or maybe it can be an active incident affecting users. It will route to the incident agent. And this is all happening from handoff mechanism, which I mentioned earlier. The triage agent will decide what the log is about, what the error is about, and we don't need to tell them which that error is. It will think from its own, and it will give the task to the specialist agent, and those specialist agent will have the tools which we will build in. This is the share context. You can see this is the share context. This is where our system prompt is. Our system prompt, whenever the agent loop happen, whenever our AI log system will trigger through any kind of error or uh, logs, this tries agent will trigger. It will see, okay, I have received the error, but what's need to be done now? It will see the shared context and system prompt. It will redirect the log to the specialist, but before giving to the specialist agent, this is where a wall is happening. This wall will make sure that it don't pass any hallucinations. This will make sure that this triage agent or this specialist agent don't give hallucinations or it don't do anything wrong in our production. And same with the specialist agent, and they have MCP tools. They will use those tools, and finally we will get a result. It can be a summary of result that what happened in the production, what I have done and what the specialist have done. There is two concept, a triage agent and an orchestrator. This is where our system is happening, and I see this way to build AI agents, and it will not only work in production, but you can use it anywhere to build your product, to build anyone's AI agents pipeline. So now we have MCP tools, model context protocol. I was actually going through MCP tools a lot. I forgot to ask how many you have experience in MCP tools.
I think we replied in the chat. Obviously, I have experience
Yes,
with MCP tools. I build also MCP tools, but yes.
I think yes, we got another one. Most of you know what MCP tools are. Okay, so for the rest of our people, I need to get to this presentation. Yes. So MCP tools, let's say MCP tools not are uh, just tools, but let's take an example of what is happening actually when we say MCP tools. It is an open standard protocol, and it have every services. It can have GitHub service. It can have many other services that I have mentioned here. You see Datadog, PagerDuty, Kubernetes, Slack, Postgres, AWS, and Jira. MCP tools, we can build MCP tools and we can also use somebody's MCP tools. And it is very important for our AI agents that it will help our AI agents to use that tools efficiently. It's discoverable, Agents enumerate available stores at any runtime and it can self-document API. These are composable, these are mix and match tools from different vendors and community publish MCP servers. So for the architecture that I have built, I actually used MCP, this architecture of MCP tools hub architecture that are AI agents that will be monitoring our logs, not only have few tools, but it will be having more than two or three tools. So I have given them a word that is hub architecture that our AI agent will call GitHub MCP, Datadog MCP, Kubernetes MCP, and so on. Now let's talk about the infrastructure layer and how we are going to deploy our AI agents that it can take the logs and orchestrate through its own. This is where actually everything runs. And when we see on the Kubernetes side, we have agents interaction with the cluster, and through the interaction, the AI agent will have Kubernetes MCP tools, which wraps kubectl. And you might be wondering why not give the agent directly kubectl access. It's because of uh, RBAC rules. You see, when we create a service account for our AI agent with exactly permission it needs and nothing more, it can actually read the pod status. It can restart deployments, but it cannot delete namespaces, which are scoped access. So we need to make our AI agents target only standard Kubernetes objects that can have pods, deployments for auto scaling, and CRDs for custom resources. And resources limits are reinforced for namespace. So an agent going rough can consume the whole cluster. And on the other hand, we have our Argo CD. This is where our GitOps come in. The principle is very simple. Git is the source of truth. We never apply manifest directly to the cluster, but instead our agent commit a change to the GitHub repo. Our AI agent will not have direct access, but it will only have the access of GitHub repo, which allows our AI agent to deploy directly, not directly, but from the GitHub itself. So why does it matter? Why it really matter? Because you have an audit trail. You know, every change the agent ever made, it can git commit, and rollback is just git revert. You can see exactly what changed, when, and why. And I think we not only give our AI agents to direct access to the cluster, but the repo. So it can change, but in the boundary of guardrails. This is the full structure that our AI agent will be having. You see, this is where our AI agent, and it commits to our GitHub repository. Argo CD detects the changes and it will apply it to the Kubernetes production. This is the architecture I'm talking about, that we will not directly giving the cluster to our AI agent, but instead we will be giving access to the GitHub repo. So let's say anything happen in our production and it will commit the changes, or it can restart the pod or anything that we have given them the issue to detect, and it will apply to the GitHub repo itself. And this is the feedback and verification loop. When our health check is going, our Prometheus, and we can get reward exactly the same time if anything happens. This is the end-to-end structure that you can
Can I add
see.
something? We have
Yeah.
around 10 more minutes. I think this session it's amazing. I learned a lot, to be honest, on MCP and all. Maybe we are still 34 people. Maybe when we have question, we can actually make it interactive. Maybe Fakri has
Yes,
question as well. So let's start having question with people. I'll
yes.
let you.
This was actually the last step.
Perfect. Now I think it's time, because we said that is 1 hour. We have around 13 minutes more. So let's
Yes,
make
we
it
have to.
interactive now. I think it was a great
Yeah.
one.
Thank you.
Yes, Fakri.
Thank you, Manas. Thank you, Manas, for the great event and for the great presentation that you have bring here. And this is a lot of information, a lot of details. That I have a questions first of all about the projects that
Yes,
you
please.
have shared everything here. And the main question is: Are you have done it on the projects, or is it possible to make it free with the free on conditions, with the free agents, and with the free MCP tools, the all what you have actually explained here? This is the first question. And the second question is that how you are leveraging knowledge of AIs on the Open SDK. If there is, you need to improve the knowledge of the agents. Thank you.
Yes, thank you so much for the question. So for the first question, I actually have built this AI agent. I have repo. I have documented everything. You can just I will share with you in the group as well. You can just run it and fork it in your GitHub and try it on your own. And if you encounter any kind of error, you can just message me. And for the second issue, the knowledge base is you see, I have talked about a system prompt. The AI logs or AI agents that is handling our logs in the production, we only need to improve its knowledge based on the logs. You see, the one we are talking about is from logs to autonomous, right? So the only knowledge it will be having is from its system prompt. It will not have any kind of other knowledge besides our system prompt, and it will only see the logs coming from our application. It will learn from that pattern.
So you mean the system outputs actually is the main knowledge for the agents? Yes.
Yeah, yes. The system prompt is our main knowledge for right now, because the one we are talking about is logs, and it will learn from the logs that it receives. And next time it happens, it will take the previous solutions, it will fix everything in just a minute.
Perfect. Thank you for your answers and for the great presentation. Guys, do you have any other
Thank you.
questions? Thank you.
You can type it in the chat as well.
I have one
Again,
question.
hi.
Yes, maybe you can ask. Please ask.
Yeah, hi. So, Kaushik here.
Mm.
So like recently we came across one scenario. I mean, I think so. I've been into the LinkedIn and I was just scrolling the browsing the LinkedIn. I came to one post where it is mentioned that like some database, which is a very critical database, have been tampered or completely deleted, right, by the AI agent, one of the AI agent. So, how can we make sure that the AI agent is not, if it is in production, if it is implemented in the production, so how we can make sure that the AI agent is not having these kind of operations, or not authorized to perform these kind of operations, or else it should
So
be
you
very
are
vigilant.
mhm.
Yeah, it should be very vigilant in while doing any operations related to the critical database.
Yes, so you are asking that how we can protect our databases, our credentials, and everything that is secret from our AI agents.
No, it's not about secrets, or you can say like
The
secrets, right?
database, no? You,
I was
mhm.
asking like how the agent, how the agent know, how we will be training the agent to not touch the critical databases, or else to be very careful or very vigilant while doing any operations. The,
How we can
um,
protect our database right now.
yes.
Yeah. So this exactly what I talk about is guardrails. You see, guardrails. What guardrails do? This is our database, and this is our AI agent. Between it, we give one layer that is guardrail. In guardrail,
Mm-hmm.
we
Yeah.
this
Okay.
is a kind of thing that we configure in our agents SDK when building in the production. We put instruction for guardrails that do not touch it. There is a function that we call in the agents SDK. We call that function and we specifically give the instruction to the AI agent that do not input or output from this resource. You do not have access to this, so don't try to query it or don't try to search for it. You only have access to this tools. In the guardrails, we can mention, we can give instructions that do not touch this or do not open or query from this database. The guardrails is the answer that you have to manage in the agents SDK.
Okay. Yeah. Thank you. Okay, so by what if some engineers have an access for the guardrails, and some juniors might have been completely changed the commands, right? So there might be a possibility, right? We just seeing the scenarios here. So if an engineer changed the commands or modified anything in the guardrails, which the agents will be considering the guardrails as an input, right? The input which we're giving in the guardrails, that will be the input for the agents. So how
You
can
see,
we?
I will talk about this in engineering. Do you have any engineering previous? Have you any experience writing in Python or any language?
Yeah, I have experienced the Python.
You see, when writing a code, we need to make sure that our code is split. Our code is split into many files so it can execute, smoothly, and we can differentiate where our guardrails is, where our tools is, and where our main agent is uh, doing our
Hmm.
work. So when
Yes.
making guardrails, we can separate the guardrails file and through RBAC, we don't give permission to the juniors. If we think that we will not be needing to change this file for now, We will not give the permission to those files, to only to the guardrails files. We will put that into any folder that we don't want anyone to access. We can import the guardrails into Agents SDK to our main agent.
Okay, got it. So what I was like, this is my idea. I'm not sure whether it will work out. It will work or not. But like, what if we train the agent itself to take the inputs from the particular guardrails and not, for example, if the guardrails have been changed, right? Even though if we're implementing the policies, RBAC policies and then IM policies, right? Who can access and the input and output for the guardrails. So even though we are implementing this, and if someone has intentionally do any changes, the agent should inform. Like there should be a mechanism where the agent should inform us that the input has been changed in the guardrails, and then it should throw an email or alert to one of the authorized person, right? And then he should verify and then he should take the decision. That would be better, right? So in like it's not a good approach to give complete access to the agents to do their operation. I believe in the production environment, the manual intervention should also be there along with the automation through agents, right? Yeah.
Yes.
May I answer
Yes,
this
please.
the for the clarification?
We have 4 minutes,
Yeah.
just for you to know.
Yes. I'm sorry, Bashur. It's actually a great approach that you have suggesting. Think about that like one orchestration agent, which is controls any other sub agents, and in that case, human could be the approver if that orchestration
Exactly.
agent. Yeah.
When making AI agents, we always need human in the loop. Before taking that action, you need to send that Slack notification, you need to send that any kind of notification before we give permission to our AI agents. And this is all in the code I will be sharing. You can just see and from basic to advanced, I have all documented it, and we have only 3 minutes left, and I think we can wrap it around.
Yeah.
Hello.
Thank you so much, Sarah. Yeah, for the great session, and yeah, we can hope like I was hoping for the more sessions like this because we discuss things further, and as a community we can learn much more things here.
Vanessa, you can invite
And
them to join the community as well, because like that you can have another
Yes.
session as well. We do every session twice a week now, and Vanessa, we can do another session next time. This one, the first time was an introduction. Maybe next time we can be very technical.